All right, guys, we're going to go over the inverse sine function in this video. So it says, recall from section 1.6 that for a function to have an inverse function, it must be 1 to 1. And I highlighted it there. That is, it must pass the horizontal line test, all right? So just a quick review, I'll write on the side here. I'll draw a sketch of a couple of functions, one that is 1 to 1 and one that isn't. All right, so on the right of the sine function that's plotted here, we have a linear function, right? So a linear function would be 1 to 1 because a linear function would pass a horizontal line test, versus a quadratic function would not pass the horizontal line test. But it says it's obvious that y equals sine of x does not pass the horizontal line test, right? Because if you were to draw a horizontal line, different values of x yield the same y value. However, when you restrict the domain to the interval negative pi over 2 to pi over 2, the corresponding black portion in 4.67, so that's this part here, on the interval negative pi over 2 to pi over 2, sine of x is increasing. On the interval negative pi over 2 to pi over 2, this is inclusive here because of the brackets, okay? Y equals sine of x takes on its full range of values. Negative 1 less than or equal to sine of x less than or equal to 1. And then finally on the interval negative pi over 2 to pi over 2, y equals sine of x is 1 to 1. And that's an important aspect there. On the interval negative pi over 2, sine of x is 1 to 1. So on the restricted domain, sine of negative pi over 2 less than or equal to x less than or equal to pi over 2, sine of x has a unique inverse function called the inverse sine function. And it's noted as such. Arc sine of x or sine inverse of x. Okay, so similar to like what we had with the quadratic function, the original quadratic function, right, or any quadratic function that that we have, it would not be 1 to 1, but so quadratic functions do not pass a horizontal line test as is, but if we restrict their domain, they can. So that's what we're kind of doing with the sine function as well. If we restrict the domain of sine of x to just negative pi over 2 to pi over 2, then the function in that restricted domain will be 1 to 1, and therefore we'll be able to have an inverse. And that's what the inverse sine function is. It's based off of that definition of it function being 1 to 1. All right. So let's kind of compare table of values for y equals sine of x and use your knowledge of inverses to graph y equals sine inverse of x from y equals sine of x. How does the domain and range compare with sine? Okay, so we're going to use a couple of values from sine. And essentially, we're just going to use the unit circle values, okay? So if we go, and so let's start at negative pi over 2. Negative pi over 2 is on the bottom of the unit circle, so we're at negative 1, and that's illustrated here. And then let's go, if we use the left-hand trick, the other unit circle values are going to be negative pi over 3, negative pi over 4, negative pi over 6, 0, and then we'll go pi over 6, pi over 4, pi over 3, and then pi over 2. All right, we know that at pi over 2, we're going to reach its maximum point, which is here at 1. We know at 0, it's going to be at 0. That's the center of it here. So if you recall the left-hand trick, pi over 6, we're going to be at 1/2. Pi over 4, we're going to be at radical 2 over 2. Pi over 3, we're going to be at radical 3 over 2. Just the y value is getting higher and higher, right, until we eventually reach 1. Negative pi over 6, this is technically in quadrant 4, and we know that sine is going to be negative there in quadrant 4. And then all these values, essentially all these values that we have here are going to go from positive to negative. So negative pi over 4, we're going to be at negative radical 2 over 2. Negative pi over 3, we're going to be at negative radical 3 over 2. Okay? So the domain of sine of x is technically negative infinity to infinity. I can plug in any number I want in for sine, in for x, and I'll be able to get an output for sine of x. The range, however, is restricted -1 to 1, right? Because our minimum is -1 and our maximum value is going to be +1. All right. So now remember use your knowledge of inverses to graph y equals sine inverse and y equals sine of x. So if we know that the range for sine of x is -1 over 1, then the domain for its inverse function, arc sine of x, is going to go from -1 to 1, right? Because we have to switch the inputs and outputs for our values here. Okay, and we know that our value for -1 for sine occurs at -pi over 2. And then our range for arc sine, right? Where is the value of sine 1? That occurs at the top of the unit circle and at pi over 2 radians. Okay. So our range has to be restricted because of the fact that we need to, it covers all the possible outputs without any repeated values. So what we'll have here, right, if we take a look at this table of values, we're switching the x and y coordinates. So we're going to go -1, -pi over 2, negative radical 3 over 2, -pi over 3, negative radical 2 over 2, -pi over 4, -1/2, -pi over 6, 0, 0 stays where it's at, 1/2 pi over 6, radical 2 over 2, pi over 4, radical 3 over 2, pi over 3, and then 1 pi over 2. All right, so let's kind of graph a little so that way we have an idea of what's happening. So we'll be at -1, +1 there. We know it's going to be a point at 0, 0. And then -pi over 2, so it's a little bit past -1.5. 2, 1, 2. Right, so it's 3.14 divided by 2, so it's about 1.55-ish. And then between, we can also plot, let's plot -1/2, -pi over 6. So it's about -1/2, -1/2. A little bit less than a half here. We'll do the same thing on the other side. And then at 1, we'll be at 1.55-ish. little bit past that. So that is our graph for the inverse sine function. It's going to look something like this. -1, 1, -1, -2, 1, and 2 along the y-axis. There, okay? So there's our sketch for the inverse sine function along with a bunch of key characteristics. And then just make sure that you guys write here how, let me just delete this here. How does, how does the domain and range compare with sine? The domain and range actually, let's do it like this. Let's clean this up. So how does the domain and range compare with sine for sine inverse? The domain and ranges will be interchanged, and we had to restrict actually the range because of the fact that our domain for arcsine was restricted from -1 to 1, and now we had to kind of shift the range appropriately as well.